Today we're working on limits involving factorization and rationalization. And then you're like, why are we doing this? Why can't we just plug in 0 right there and find the limit by substitution? Well, the limit law for division cannot be used in these questions. Why not? When you put the 0 in for x right there, that will give you a 0 in the denominator. That's why you cannot use the limit law for division in these notes for today. But other than that, you would be able to unless you get a 0. Okay? So the first thing we need to do is we need to expand this binomial right there. So, and remember that the squared right there on top of the binomial means negative 3x plus 3, negative 3x plus 3, multiplied by itself twice. So you can do FOIL or you can do the formula here. Either way, I'm just going to do the box just to look better and nicer on my notes. But as you're working it out, you can do FOIL if you prefer. So when you multiply negative 3x times negative 3x, you get 9x squared. Multiply negative 3x times 3, you get negative 9x. Multiply again, negative 9x again. Multiply these two, you get 9. Okay, when you combine everything, you clean it up, you get 9x squared minus 18x plus 9. Okay, so I will rewrite this question in the expanded form right there for this binomial. So here I have the limit as x approaches 0 of negative 3x over, now I have this right here, 9x squared minus 18x plus 9. And then I have the minus 9 from right there. And then I will clean it up and simplify what I can. So plus 9 minus 9 is 0. And on the next step, I will go ahead and factor this thing out. You can, let's go ahead and pull 9x from the denominator. So here I have the limit as x approaches 0. So factor this out, I have 9x, leaving me with x minus 2 inside parentheses here. So now I have to simplify this rational function right here. So x with x simplifies, and I have 3 and 9 leaves me a 3 right here in the denominator. So finally, we have the limit as x approaches 0 of negative 1 I have left on the numerator over 3x minus 2. Now at this point, I can go ahead and substitute 0 in for x. So negative 1 over 3, 0 minus 2. So I have negative 1 for numerator. 3 times 0 is 0, minus 3 times 2, I have 6. 2 negatives make a positive. So therefore, the limit as x approaches 0 of this function, everything boils down to 1 over 6. All right, that's first one. Second one, when I look at the denominator, I think difference of two squares. Difference because I have a minus between two perfect squares. And that's what I'm going to do. I will start out by simplifying. If you can factor, you can factor it over to the side and bring it all back together. I will just factor as I go. So limit as x approaches negative 4 of x plus 4. Now remember that when you're factoring this guy, the difference of squares, I have x plus 4, x minus 4. And you are only able to simplify this function if your numerator and denominator are the same. It's a binomial that is the same. You cannot just cross the x with the x right here. They have to be the same binomial. In this case, I am in fact able to simplify that, leaving us with the limit as x approaches negative 4 of 1 over x minus 4. And then at this point, I can go ahead and evaluate the limit by substitution. So the next step, you plug in negative 4 for x right there. That simplifies down to 1 and then -8. So the limit as x approaches -4 of this function is -1/8. It gets easier after you've done a couple of them. 2 more. Now, number 3, we will have to rationalize the denominator. What does that mean? Well, we need to get rid of that thing because it's too ugly. And it's okay. So again, if you were to plug in, evaluate the limit by substitution. When you plug in 36 under the square root, you get 6. 6 minus 6, that will leave you the 0 in the denominator. And that means you cannot use the limit law for division. So that goes that. That's why you have to do the rationalization of the denominator. How do you do that? Well, you will multiply numerator and denominator by whatever you have here. But you have to do this with the different sign of that. So if that is negative, you need to multiply by square root of x plus 6. Okay? Be careful with that because the sign has to be different than this sign. All right. Instead of doing the box for the top, let's just leave that alone. So we have 2 binomials there. So don't do more work than what you need to. All right, and here I'm going to show you how to do the box on this one. And again, you can do FOIL. But then after you do a couple of them, you are going to come up with the rule or the shortcut, if you will, of how this thing works. But since it's the first time that you see it, I just want to show you how it mathematically makes sense. So square root of x, and then we have positive 6 here. Square root of x, we have negative 6 here. Square root of x times square root of x, you have x. Here we have 6 square root of x. Here we have negative 6 square root of x. And here we have negative 36. So when you combine negative 6 square root of x with positive 6 square root of x, you have 0. So here you just have x minus 36. Okay, you will be able to come up with the relationship right there real quick. Okay, so here I have x minus 36 left over after I multiply this binomial by this binomial. All right, you're like, hey, it's looking good. I'll be able to simplify this guy and this guy. And that's true. That's where we are. So we have limit as x approaches 36 of this function now plus 6. So at this point, I can just go ahead and do substitution. So plug in 36 for x. So square root of 36 plus 6. Square root of 36, I know it's 6. Plus 6 is just 12. You didn't think it was going to look that pretty, huh? All right, last one. We're going to have to do some factoring here. And I will factor it out to the side. So I'm going to do the orange right here. So I have 2x squared, 6x, and 4. I will pull the GCF out. So that means I have to divide everything by 2. And I still need to keep on factoring. You have to factor it completely. So I'm looking for 2 numbers that multiply to 2, and same 2 numbers that add up to 3. So 2 and 1. All right, since I'm looking at the denominator, I know I'm going to have to factor that out too. So I will use the light blue right here to factor it out. So I have 3x plus 6, factor the 3 out. That gives me 3, and then x plus 2. All right, let's bring it all together. So this is the factored way of this. And here I have the denominator. Okay, simplify what you can. Rewrite the function or the question So the limit as x approaches -2 of your new function here, 2, x plus 1, and then over 3. At this point, go ahead and evaluate by substitution here. So you have the limit as x approaches -2, so go ahead and plug in -2 for x. And here I have -1. -1 times 2 is -2 over 3. So all this work, and that's the limit as x approaches -2 of this function. It's approaching -2/3. That's your answer right there. Goodbye.